Hello, welcome back. In this video, we're going to go over solving a trigonometric equation. And first, I want to remind you what a trigonometric equation is. It's essentially an equation that involves trigonometric functions like sine theta, cosine theta, tan, cotan, secant, or cosecant theta. So in this particular case, we have cosine theta equals negative root 2 over 2. So this is an equation and that involves a trigonometric function. So essentially we are looking for an angle theta or theta value for which cosine of that is going to be negative root 2 over 2. All right? So to be able to handle this problem, I just want to remind you a few facts from trigonometry. Here we go. So first off, if you have a right triangle, as you see, and if the angle theta is placed here, cosine of that angle is defined as adjacent to that angle divided by hypotenuse. Okay, so cosine first off is defined by adjacent divided by hypotenuse, and in fact, if we go to a circle of radius r, cosine of that angle, in other words, would be the x-coordinate of this point, x-coordinate of this point, divided by the radius of the circle. So in particular, if you are talking about a unit circle, so that means the r here is going to be all 1 here because the radius is 1. And as you see that, if you choose points on the unit circle, we know that cosine of any angle that we pick is going to be the x-coordinate of that point, and sine of that angle is going to be the y-coordinate of that point. This in mind, going back to the trig equation here, so we're given cosine theta to be negative root 2 over 2. So here, first observation is that negative root 2 over 2 is a known number on the unit circle. As you see, like you have 30, 45, 60 degrees, and then 120, 135, 150 degrees, and then these are the radian versions of those. Pi over 6, pi over 4, pi over 3, and 2 pi over 3, and so on. So if we can recover a point whose x-coordinate is negative root 2 over 2, we're done. Okay, let's check. Well, 45 has, or pi over 4 radians corresponds to a point whose x-coordinate is root 2 over 2, but still I'm looking for minus root 2 over 2. So here x-coordinates are all positive, so this first quadrant is not going to be spitting out any theta for me. But in the second quadrant, as you see, this angle, 3 pi over 4, right, has the x-entry on the unit circle to be negative root 2 over 2. So I'm going to go ahead and then write that theta could be 3 pi over 4. Right, the x-coordinate here is negative root 2 over 2. And there's another point here whose x-coordinate is negative root 2 over 2. That is 5 pi over 4. Okay. And if you look at the fourth quadrant, the x-coordinate is root 2 over 2, so this is not the case. So once we find all possible theta values in between 0 and 2 pi, by adding integer multiples of 2 pi to each of these solutions, we obtain general solutions. So here, general solutions would be 3 pi over 4 plus 2n pi. Again, we're adding multiples of 2 pi. And then 5 pi over 4 plus 2n pi, and here n is an integer. So by just picking n as an integer and then substituting back to the general solution, then you got the pair of solutions that would satisfy cosine theta equals negative root 2 over 2. So this way we get infinitely many solutions. So the question is like, if you don't have the unit circle in hand, I would totally recommend you to sort of like memorize the points on the first quadrant. And then since these are x and y and entries of the points, so you can actually flip them, take the symmetry about those with respect to y-axis or x-axis or the origin to come up with other angles having almost the same type of known values, but well, they're going to change up the sign basically. For example, if you have a 45 degrees here, you know that cosine of that angle is going to be root 2 over 2, and sine of that is going to be root 2 over 2. So if you're looking for cosine theta to be negative root 2 over 2, you can take the symmetry of that point across the origin. So you will know that this point would come with x and y coordinates to be negative of what we have here. Or if you take the symmetry of that about y-axis, you will know that x coordinate is going to be negative of what you have here, and y coordinate is still positive. All right, so I think that's all for this video. Please let me know if you have questions or comments, and put them down the video, and then I'll try to get back to you as soon as possible. Thank you.